Hi everybody, so today we're going to be going over numbers. What are numbers, the different kinds of numbers. So first we have here real numbers. Real numbers are basically just any number. And I have this little diagram over here, a circle with a bunch of concentric circles inside so that you can really understand what is included in what. So in real numbers, any other kind of number can be included in this except for complex, which we won't have to worry about for now. So it's any number, positive or negative, decimal or fraction, rational or irrational. We'll go over what those means in a few minutes. Next, we have an integer. Integer is the next ring. An integer is kind of like a counting number, except that it includes negatives and positives. So they can include -3, -2, -1, 0, blah, 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 all the way up. They can be positive or negative, as I just said, but there is no decimal and there is no fractions. Now, whole numbers. Whole numbers are what we consider counting numbers. They're the next ring over here. They're considered counting numbers, except they start at 0, they don't just start at 1, and they are increasing. Next, we have natural numbers, which is the innermost circle. Natural numbers are what we consider counting numbers, how we actually count objects and things. They start with 1. So here I would like to just try something. We'll try and identify what these numbers are based on our definitions, and we'll identify them as R, I, W, or N, real, integer, whole, or natural. So first, -3.333 repeated. So is this a real number? Yes, it is. Is it an integer? Well, it has a decimal. Whole number still has a decimal. So once we decide what's the outermost circle it could be between the innermost, we'll know that it has to be the one right outside of that. So this is a real number, but it's not an integer. Now we have root 36. Well, root 36 is actually equal to plus or minus 6. That is going to be an integer. It's a positive or a negative number. Next we have -17. -17 is, well, is it real? Well, it's positive, negative, it has no decimal and fraction. But how about, is it an integer? It's positive and negative, no decimal or fraction. Looks like that is an integer. We're trying to find the innermost circle that could possibly be in. Next, -5/3. Well, positive or negative, it could be a decimal or a fraction, but the next round is integers. Well, that says that you're not allowed to have a decimal or fraction. So 5/3 is a real number. 0. Well, there's no decimal and no fraction, we're still good. And 0 is included in the whole numbers, so this is going to be a whole number. Lastly, 4. Well, 4 is positive. It's included in the counting numbers, and it's included in natural numbers. It's a natural number. But here's one thing. For whatever the innermost identification can be, it also is included in every single outer one. So for this one, it's an integer, but it's also a real number. It's an integer, but it's also a real number. For whole, it's also an integer and also a real. And for natural, it's also a whole, an integer, and a real. Next thing we're going to talk about is absolute value. Absolute value means the distance of a number from 0 on a number line. In other words, it just means the positive value of the number. So for example, if we take the absolute value of -2, how far away is that from 0? Well, that's 1, 2 spaces away. But if we take it of +2, it's also 1, 2 spaces away. So it basically just means the positive value of the number. So absolute value of -7 rather, is 7. Absolute value of 5 is 5. Absolute value of -2.17, positive 2.17, because it's positive 2.17 spaces away. Here we have 5.89. Absolute value of 0 is 0. It's 0 spaces away from 7. Here's a tricky one. The negative of the absolute value of 18. So now we have negative. On the inside we'll have 18, which is just -18. And here, negative absolute value of 13. Now we have negative of the value of 13, -13. Next, as I mentioned earlier, we're going to go over something called rational and irrational numbers. First of all, rational number is a number that can be expressed as a ratio of A to B. how can we identify this without really looking at it in these complicated terms? Well, 1, it's going to terminate or repeat when it's written as a decimal, or 2, it can be written as a fraction. So these are some examples. -1/4, 1/3, these are fractions. They are therefore a rational number. 5, just a regular integer or whole number, counting number. 0.1 is a decimal, but it terminates. 0 is a terminating number, and 0.4 repeating. It's a decimal, but it repeats. Now, irrational numbers rather cannot be expressed as a ratio of a to b. So these are numbers that will never end. √2, for example, will never end. -√3 will never end. This decimal keeps going on and on and on. Same with these special numbers, pi and e. So let's look at these and consider if they're rational or irrational. √17, well, that's a decimal, and √17 does not end nicely, so that is irrational. 2/9, that's a fraction, rational. 0.45 repeating, well, it's repeating, rational. √4 is plus or minus 2, which terminates rational. 0.67, it terminates rational. 3.14, that looks like pi, but it's actually just 3.14. It terminates rational. √21, it's a weird decimal when you break it down. It does not terminate, it is irrational. So that was the first topic. Click to the next video if you want to watch the next. Thanks, guys.